What I have here, ladies and gentlemen, is the rest of the story of that tangent that we talked about last time. In fact, there's three major trigonometric functions or trigonometry functions. You've heard of that word trigonometry before. And so we are actually dipping our toes in trigonometry. And so the rest of it is dealing with sine and cosine. Most of the time, it won't be like this with the E on the end, or even looking like this. Sine is usually S-I-N, and say sin. Please, say sine. Cosine is not cos. It's a C-O-S, but this is really how they're spelled out. In fact, we see them on a calculator, and that's how it's usually done. You got sine, cosine, tangent. These are the three major trigonometric functions. All right. And so today we're talking about sine and cosine. Both sine and cosine deal with the hypotenuse. If you remember, tangent did not talk about the hypotenuse. So the first thing I tell everybody when you're talking about trigonometry or sine, cosine, and tangent is you have to know which angle is your orientation. Where are you starting from? Because it's very important, because sine and cosine changes depending on which angle you're talking about. First off, it's not going to be the 90 degree when you're talking about the right triangle here. It's going to be your acute angles, okay? Trigonometric ratios for the acute angles that involve the lengths of the leg and the hypotenuse. That's basically saying the legs and the hypotenuse, and C and A, or your acute angles, is really what we're talking about. So what do we really need to know? Well, the sine is the opposite over the hypotenuse, depending on which angle you're talking about. Sine of A is this side over the hypotenuse. Sine of C is this side over the hypotenuse. So it depends. So sine of A is BC over AC. And sine of C would be BA over CA or AC. Now, cosine is adjacent over hypotenuse. Adjacent to angle A would be this side here over CA, and adjacent to C would be this side here over this side. Remember last time we talked about adjacent. For each acute angle, you're going to have two sides that are really adjacent. For example, see here, this side and this side are both adjacent, but this one is the hypotenuse, so it don't count. This is the adjacent side over the hypotenuse, okay? So it's important, again, for y'all to know which angle you're talking about. Which angle is our focus, all right? This is what it really means. The sine of a right triangle is opposite divided by hypotenuse. The cosine of a right triangle is adjacent divided by the hypotenuse. And another way to kind of remember that is this word SOHCAHTOA. It's almost like PEMDAS, but it sounds like a Native American who was helping us do the math country way before the Americas was formed or something. But it's SOHCAHTOA. And what that really means is this. Sine really is opposite over hypotenuse. Okay, this is a cool way to remember it. Like when you write this down on your papers, like when you put your name on, write this down. It'll help you keep them in order. Cosine is really adjacent over hypotenuse. And tangent, the one we've already talked about, is really opposite over adjacent. So, if you forget it, SOHCAHTOA. Alright, you got it? Alright, let's do some problems. Find the sine and cosine of R and of S. Alright, they want us to find the sine and cosine of R and S. Alright, so let's look at this. Let's start off with R first. The sine. Okay, if you forgot, let's go back and look. The sine is opposite over hypotenuse. Okay, so we're talking about sine of angle R. Alright, so sine of R. We just can't say sine. We got to know which angle we're talking about. So sine of R is opposite over hypotenuse. So that's 8 over 10, which is the same thing as 4 over 5. We can keep it like that for right now. I know it said decimal too, but we'll just keep it like that for right now. The cosine of r, again, we need to know where we're talking about. The cosine of r is adjacent next to over hypotenuse. So the cosine of r will be 6 over 10. And as always, any fraction you get, you always reduce. Oh, that should be a 3. Sorry. 3 over 5. Okay? So cosine of r and sine of r. Let's talk about the sine of s, angle s. The sine of s is opposite over hypotenuse. So 6 over 10, which is 3/5. Let's make that a little bit bigger. And the cosine of s equals, again, here's s, adjacent over hypotenuse. I said 35 up here. Come on now, why y'all didn't say that? That should be 3/5. And that's 4 over 10. Now, you know anything? Notice anything, I mean? Depending on which angle you're referencing, those will be the same. Those will be the same. It's important though, because each one of them has its own value that you know what the orientation and which function you're going to use. Now, in this next example here, this is kind of where the rubber hits the road, so to speak. Because a lot of people don't really understand the idea of sine and cosine and tangent. What actually happens is you're able to use any one of them on any given problem based on what you know and what you're trying to find out. Did you hear what I said? You can use any one of them on any given problem based on what you know and what you're trying to find out. In this particular example, I need to find A and B. Let's look at what I know. I know that this angle right here is 50 degrees. I know that my hypotenuse is 10, whatever, 10, and I need to find A and B. So what I need to consider is, what information do I know that's going to help me figure out A, for example? Let's just start at A. Well, according to angle 50, A is the adjacent side. Does everybody understand that? Yes, Mr. Freeman. A is adjacent to the 50, and 10 is a hypotenuse. Which one of our functions deal with adjacent and hypotenuse? Which function deals with adjacent and hypotenuse? Look at your notes. And if you wrote that down, you would notice that cosine is adjacent over hypotenuse. Right? So here's how you would find out angle A. Side A, excuse me. Cosine of 50. Remember, whenever we put a number in there, we use parentheses. Close it up too. Cosine of 50 equals adjacent over hypotenuse. Okay? You can have an X there, A there. That's what I'm trying to find. Now that we have our proportion, it's basically cross multiply. Okay? Okay, so little technical difficulty there. Then you cross multiply, and when you cross multiply, you get A equals 10 times the cosine of, put a little dot there so you know I'm multiplying, 50. Alright, so what you want to do here is, the calculators can be funny things sometimes depending on which mode it's in. And if you hit mode there, you see at the top degree, radians, gradients, and stuff. For our purposes, we're going to stay in degrees. So I hit second and quit, or mode. Why? I just want to make sure I was in the right thing. So when I hit 10 times the cosine of 50, close it up, you get A equals 6.4. Let's just keep it at 6.4. Okay? So we found A equals 6.4. Which if we wanted to, we might could apply the Pythagorean theorem and 6.4, 10. But let's continue using the trig functions. If we're looking at b and we want to find b, we have to consider that what we know is 50 and the angle 50 and the hypotenuse is 10. Now, according to angle 50, b is the opposite side, and 10, of course, is a hypotenuse. So what do we know that deals with the opposite and the hypotenuse? Well, the function, again, that deals with that is sine, which is opposite over hypotenuse. All right? Sine is opposite over hypotenuse. So we're going to use that. Sine of angle 50, and again, use parentheses, close it up, equals b over 10, opposite over hypotenuse. That's where I'm getting that from. And you got your proportion here, so you cross multiply. So that's b, 1 times b is b, equals 10 times sine of 50. And again, I always like to put the number in front, the number that you're multiplying by, and close up that angle like that. And when you do, if we do 10 times the sine of 50, we get b equals 7.7 when you round. Alright, so we get a and b based on the sine and the cosine and things like that. Now, tangent, cosine, and sine are all trigonometric functions that allow us to find relationships between angles and sides of that nature. Real quick, I want to go back to one of the original problems here real quick. I have this written here. If I wanted to know the angle R here, it's kind of tore out there, but that's angle R. You can use the inverse sine and that relationship to tell you what the angle is. And so let's try that real quick. Second, I hit second, and I do inverse sine of 4 divided by 5, close it up, same thing as 4 over 5, and you hit enter and you get approximately 53.13. Alright, let's see if the cosine of that same angle, different ratio, will give me the same thing. Second, cosine, because I'm trying to find an angle. Remember, you only do the inverse. That means inverse. You only do the inverse sine or inverse cosine or inverse tangent if you're looking for an angle. And on all the rest of these, I wasn't looking for an angle. I was just looking for the ratio. Sure enough, look, I get the same decimal. Why? Because it's the same thing. That's absolutely right. So what am I telling you there? I'm simply saying that if you're ever asked, based on the sides of a triangle, something like this problem here, they give you all the sides, and you need to know an angle, you can find the angle. It's called the inverse sine, and it's usually on top of cosine, sine, and tangent, and you have to hit second or shift or whatever, depending on your calculator, to get there. So again, in these problems, we don't go into them assuming we already know which ones we're going to use. We allow the problem to tell us, based on what we know, which function we're going to use. Do not automatically say, on this one I'm going to use cosine, on the next one I'm going to use tangent, and on the next one I'm going to use sine. It doesn't work that way. You have to let the problem and what information you know tell you which one you want to use on that particular problem. Don't forget this. SOHCAHTOA is something that I haven't forgot for 1,000 years. It's something I still use and remember.